Yes, Mr. Rasmussen here. Where we have been, we've been talking about these macromolecules that are important for living things. And we're going to continue, but we're done talking about the macromolecules. We're going to talk about a different molecule that's important for living things. And this molecule is so important for living things that when we are searching the outer space for planets that may possibly contain a living organisms, this is the thing we're looking for. We are looking for water. Because we know that without water, these planets cannot contain life. Without water, as we know it, life is not possible. So water is important. To have a good understanding of water is important to understanding living things. So water is essential, which means that without it, living things cannot exist. We would not have evolved on this planet if we did not first come from an aquatic environment. Water is essential. We're built around water. We haven't lived in water for thousands of years, millions of years, but we still need water to survive. We haven't been able to separate ourselves from this molecule that is so important to living things. It is essential. Now, this is an important statement. Water has unique properties that make it essential for life. What I mean by that is this. Water has things about it that are unique. It doesn't act like any other molecule. This molecule down here, this one oxygen, and this is the oxygen out here, and these two hydrogen atoms, make this molecule really unique. They make it its own individual unique molecule, and its unique properties, what makes it different, make it essential. It's these properties that make it essential for life. So we're going to talk about what properties water has that makes it essential for life. The first thing that water has that's odd is something called polarity. Water is a polar molecule. Water is a polar molecule. And this is over here, this is an example of the dipole. But I sort of want to explain what this means. So water, one side of the molecule has a positive charge, and it's actually this side down here. And one side of the molecule has a negative charge. And that actually happens because oxygen, the oxygen atom, is what we call highly electronegative. The best way to think of that is oxygen is a big jerk. It likes to grab all the electrons. It likes to grab all the electrons and hold it close to the oxygen. So all the electrons, oxygen's a big jerk, and it grabs electrons, and it hoards them. Keeps them next to it. If you've ever seen hoarders, it hoards them. Which means that most of the electric charge, or most of the negative charge, is gathered around the oxygen atom, which makes oxygen have a partial negative charge. It's not a full negative, but it's a partial negative charge. And it makes this end, the hydrogen end, have a partial positive because all the electrons are missing. They're up here. That partial negative charge and partial positive charge make water do some pretty interesting things. For instance, these charges will allow water molecules to stick together, forming hydrogen bonds. So if we look down here, well, let's actually zoom this in so we can look at it. Hydrogen bonds are much weaker than the bonds that hold hydrogen and oxygen together. So it's a weaker type of bond than this bond here, than the bond holding this oxygen and this hydrogen together. It's a weaker bond, but it is still a bond that holds the water molecules together. For instance, if we look at a zoom-in picture of this, here's this water molecule here, and we remember that this oxygen has a slight negative charge, and these hydrogens have a slight positive charge. Well, this negative charge on the oxygen is attracted to the positive charge on a hydrogen, just like a magnet. If we take a magnet here and we have a north pole and a south pole, and we put another magnet next to it with a north pole and a south pole, this north and south will attract each other. These opposite charges attract. So over here, the opposite negative is attracted to the opposite hydrogen, and these two water molecules stick together. They stick together, and then they'll form these water molecules stick together, and these water molecules will stick together, and therefore we have a whole bunch of water molecules that are stuck together. This allows the water to stick together, and it forms little droplets when it comes out of your sink. That's because all these little water molecules in here are stuck together. That's important. This polarity of water allows it to do a bunch of really interesting things. The next one, and this is directly because the water molecules stick together, is water has cohesion and adhesion. And cohesion is water's ability to stick together. For instance, if we look here, instead of forming a sheet, water forms these little droplets. They clump together in droplets. And that's because of that hydrogen bonds between the oxygen and hydrogens, and those little water molecules like to stick together. They form drops. Water also has adhesion, which means it can stick to other things. For instance, this water is grabbing onto this spider web here. So water actually adhedes to the spider web while cohedes to itself, forming droplets. Make sense? Okay, let's move on. The other thing that water does that's really good, and this is because of these hydrogen bonds, these hydrogen bonds make it harder for these water molecules to break apart from each other. So because of that, water has a high specific heat, which means that if I take, if I'm going to heat something, so here's my pan on the stove. There's my stove. And I'm going to heat this up here. I have to put a certain amount of energy in order to raise the temperature. Well, something with a high specific heat means that I have to put a lot of temperature in. I have to put a lot of heat in before the temperature goes up even 1 degree. So it means that it takes a long time for water to heat and cool up. Specific heat is the amount of energy required to raise 1 gram of water 1 degree. So it's the amount of energy I need to put into something in order to raise 1 gram 1 degree Celsius. Oops, I want to go back for just a second. So because of that, if you think about this, water in its solid form, all the molecules are sort of locked together, right? So if we have ice, all these water molecules are locked together. They can't move. Well, in order for them to break free and become water, to become liquid water, these water molecules have to be able to freely move. Well, these hydrogen bonds help lock them together. They help connect them, so it makes them harder or take more energy to go to the liquid form. Same with liquid. In order to go from a liquid to a gas, these particles need to completely break away from each other and fly off. While these hydrogen bonds hold them together, so it takes more energy for them to go from the liquid to the gas state, which means it takes more energy for them to change states. And that's really important for water. This is good for life. Because if we have water here, and I'm a little fish in the water, so I'm this fish, I don't want the temperature of the water I'm in to change drastically. If this water goes from 100 degrees one day, that's Fahrenheit, 100 degrees Fahrenheit one day, to negative 30 degrees Fahrenheit the next, that's going to make it really difficult for this fish to sort of live in those conditions because its body has to adapt to huge temperature ranges. But since the temperature of water only changes from 1 degree to the next, or about 1 degree from each day, then it's really easy for it to adapt to its surroundings. So that's good for life. Next, density of ice. Ice does a weird thing. The solid form of water is less dense than, oops, I just crossed that out, than the liquid form. This doesn't happen. Normally, if we take a solid, and say I take a solid block of aluminum, and I put it in the melted liquid aluminum, normally it sinks. Right? So the solid form is usually more dense than the liquid form, which means the solid sinks in the liquid. But ice doesn't work this way. Ice works the opposite way. The solid is actually less dense, which allows the solid to float in the liquid. This is important for living things. Whoops. This is important for living things because if you were a fish, so here's our lake again. If you're a fish, it would be really bad if a sheet of ice formed and then that sheet of ice fell to the bottom of the lake and then started freezing the lake from bottom up. If ice didn't float on water, lakes would freeze solid. But because ice floats on water, that allows the ice to form a sheet on the top that insulates the water underneath, keeping it a decently moderate temperature, and allows living things like me the fish, which I'm not actually a fish, but allows me the fish to live in it. That's really important, density of ice. The other thing water does, and I'm not going to spend a lot of time on this, but water forms solutions, which means water is able to dissolve a large number of substances. It can dissolve liquids, solids, and gases. We can dissolve other liquids in water. We can dissolve solids like sugars and salts. And we can even dissolve gases like carbon dioxide to make our soda beverages into water. So water can dissolve a large number of substances and form these solutions. Now, a solution, I'm going to give you some definitions, and this is where we're going to stop today. Just make sure you write these down and memorize them. A solution is where we have one substance evenly distributed in another substance. A solute is the substance that's being dissolved. And a solvent is the substance doing the dissolving. The best example I can give of this, and I'll put it down here, if I have a mug of hot cocoa, here's my mug of hot cocoa, right? And I'll have some hot water in here. And then over here I have a spoon in which I am going to have on it hot cocoa powder. Here's my pile of hot cocoa powder. Let's talk about these things. So right here, the hot cocoa powder is the solute. Those are the particles that I'm putting into the water, which is the solvent. When these two completely mix together, that forms a solution. So solute, solvent, solution. Make sure you know those terms. If you have any questions, class, feel free to ask me anytime. Thank you very much. Have a good day.